All right. Welcome back to Mrs. Bailey Math. I said MBM. Please subscribe below. Graphs of logs. Today we will be investigating the graph of logarithms and how it's related to the graph of an exponential. Using your graphing calculator or Desmos, complete the questions below with your group. But we don't need a graphing calculator because we know how to graph. And with the problem, we are doing our x is our input, our y is our output. We're going to input this negative 2. 2 to the negative 2 power is 0.25, 1/4. Because remember, whenever you have a negative exponent, you flip it. And 2 squared is 4, so that's 1/4. 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the first power, 2. 2 to the second, 4. 2 to the third, 8. 2 to the fourth, 16. All right, now they want us to be able to graph these points. So when our x is negative 2, our y is 1/4. When our x is 0, our y is 1. When our x is 1, our y is 2. When our x is 2, our y is 4. When our x is 3, our y is 8. 1, 2, 3. And when our x is 4, our y is 16. And we have an exponential graph. Now, they want us to complete, and this is called our f of x function. All right, they want us to complete this table for both our f of x and our g of x. Right now we have our f of x intercepts. Where does it crosses the axis? A-axis. What coordinate? It crosses the y. What coordinate? So that is at 0, 1. When our x is 0, our y is 1. The domain. We recognize domain as our what values? That is our x's. So the domain of this graph, which goes forever to the left and forever to the right, is from negative infinity to positive infinity. So that is all real numbers. And we can represent it by this R. The range, if the domain is our x, the range is our y's. The y's which goes up and down. This graph does not go lower than what y value? 0. It gets as close and close to 0, but it will never cross 0. So the range, which is our y value, is all real numbers greater than 0. And the last part is our asymptote. Our asymptote is where this graph gets closer and closer to, but it will never cross. That is at y equals 0. Now they also want us to do the table for our g of x function, log base 2 of x. So we're going to plug in the x and get our y back. So log base 2 of 8. That means 2 to what power give me 8? 3. Log base 2 of 4. 2 to what power give me 4? 2. Log base 2 of 1? 0. Log base 2 of 1/4? -2. Log base 2 of 0? Not possible. You will get an error. Error also with negative. I'm going to change the color, and I'm going to plot this function. When our x is 8, our y is 3. When our x is 4, our y is 2. When our x is 1, our y is 0. When our x is 1/4, our y is -2. So now we have points for our logarithmic function. Our logarithmic function is called our g of x. And we need to state what is the intercept of our logarithmic function. Where does it crosses the axis? 1, 0. The domain, which is our x value going from left to right, this function, logarithmic function, is not going past what x value? 0. So it is not going past 0, so that the domain is all real numbers greater than 0. The range, which is our y value, going up and down. This graph goes down forever, and although slanted, it goes up forever. So our range will be all real numbers. Our asymptote. Our asymptote is where the graph never touches. Our graph will never touch where our x equals 0. All right. So for the f of x function, we had 0, 1, which is our y-intercept. For the log function, we didn't have a y-intercept. We had a what? We had an x-intercept. And also, as you can see, our x and y switches. Switch. We also see a switch in the domain and range. There's a switch between our domain and our range. What was the domain for our exponential became the range for our logarithmic. What was the domain for our logs became the range for our exponential. And we also switched our y and our x asymptote. That is the reason why we said that exponentials are inverses or opposite of each other. Now, for number 5, it says add the line y equals x to your graph. Change the color. If we're adding the line y equals x, that means whatever my x is, my y is as well. So when my x is 0, my y is 0. X is 1, y 1. 2, 2. 3, 3. Same thing, negative. Negative 1, negative 1. Negative 2, negative 2. This gives us our y equals x line. All right. F of x and g of x are reflections over the y equals x line. That's why they are inverses of each other. They are opposite. The only thing different is whatever was my x for one is now my y. Whatever was my y for the other is now my x. All right. Does anyone need this part? I got this. All right, I'm going to go down to 5. So what do we notice? We notice that g of x is a reflection of f of x over y equals x. They're inverse functions. And how do the intercept domain, range, asymptote of the exponential functions relate to the intercept, domain, range, and asymptote of the logarithmic function? All of the x's and y's switches. Inputs becomes the outputs, and outputs become the inputs. That's quick notes, practice, and we done. All right, we got this. All right, graphs of logs. I'm just going to split this up in two. Right side a little bit bigger. Learning tip number 1 and 2. Graph of a log. When we're dealing with graphs of logs, we're dealing with a graph that has an x-intercept at 1, 0. We have an asymptote at x equals 0. Which is vertical asymptote. You will be x'd at. All right. When we talk about our domain is our x values. The only x values that are being used is all real numbers greater than 0. Range, which is our y values, this graph goes up forever and down forever. So our range is all real numbers. And we have to talk about the inverse. The fact that these are inverse of each other, they are opposite. We have the exponential that shows an exponential growth. And we have our y equals x line. A logarithmic. When we talk about exponentials, when we get a coordinate a, b, that coordinate for the logarithm will be its opposite, b, a. And that's it. We're going to do some check your understanding, and then we're going to do some delta math. All right. Use your calculator to graph each function. Then find the intercept, domain, range, and asymptote. We don't need a graphing calculator, we know. So, log base 3. Log base 3 of 3 to what power would give me 3? 1. So if I input a 3, I output a 1, so I could put a mark there. Three to what power is, how far this goes up? Three to what power is 1? So I plug in a 0, I output a 1. 3 to what power is 9?
Two.
2. So when I input a 2, I output a 9. Wait. No, when I input a 9, I output a 2. I'm sorry. I said that the wrong way. When I input a 2, I output a 9. So it's right here. And 3 to what power is 1 over 3?
Negative one.
-1. So if I input a 1/3, I output a -1. All right? And we could create 1, 2, 3, 4. We got 4 points. Create our logarithmic function. All right. Now, what is the intercept? What does it crosses the axis? 1, 0. The domain. The domain is our x values. This x value, our domain, does not go past what x value? 0. So our domain is all real numbers greater than 0. Our range, which is our y value, go up and down. The range of this graph is all real numbers because it goes up forever and down forever. And then the asymptote, where the graph will never cross. The graph will never cross where x equal 0. Now they want us to draw another graph on the same plane. I'm going to show y'all how we could do this. Change my color. We're going to plug in to try to get this to a value that we could use. Like if we did log base 3 of 3, that means 3 to what power gives me 3? And we know that is still 1 power. So in order for me to get 3 in here, what does my x has to be for me to get 3? 7. My x would have to be 7 for me to get 3. Log base 3 of 3 is 1. 1 plus 2 is 3. So when I plug in a 7, I output a 3. Now I can change this to log base 3 of, give me another one. If I want to change this to log base 3 of, I did log base 3 of 3. Log base 3 of 1. That means 3 to what power give me 1? 0. So that means my x has to be what for me to have this equal to 1? 5. So I plug in a 5, and I have this log base 3 of 1 being 0. 0 plus 2 is 2. So when I plug in a 5, I output a 2. And then I could do log base 3 of, log base 3 of 1/3. Log base 3 of 1/3. So 3 to what power will give me 1 over 3? Negative 1. All right. So in order for me to get this to equal 1/3, it will give me a fraction. All right. In order for me to have this equal 1/3, this would need to be 4 and 1/3. So when our x is 4 and 1/3, our y, that would give us a -1. -1 plus 2 is 1. So 4 and 1/3, our y would be 1. All right. So it gets closer and closer to this line. All right. So we had an asymptote here when our x equals 0. Now, our asymptote is here at x equals 4. All right, let's explain the transformation. What happened to our function? From the blue to the red, it shifted to the right how much? 1, 2, 3. All right, we could base it off of the asymptote. This asymptote was at x equals 0, so it shifted to the right by 4. So this is right 4. Also, we had it starting on our x is 0, but now it is on our x's went up 2. So this point moved up 2, so this is also up 2. And we could tell from the equation. -4, remember, inside you move opposite direction. So I don't move to the left towards the -4, I move to the right. That +2, I could put that at the end, and that could be just like my midline. That is also called my shifting, my vertical shifting. All right, so transform intercept. We had an intercept at 1, 0. Now it changed to, because we went to the right 4, which changes our x value, 1 plus 4 give us what as our new intercept? 5, 2. Because our y was at 0, and since it lifted up 2, that affects our y-axis. So it moved to the right 4, so our x was added 4, and went up 2, so our y was added 2. And then we need to change our domain. Our domain, which is our what value? Our x value. Is our x value does not go past 4. So it is all real numbers greater than 4. Range is our y value. Our range, which go up and down, this graph goes down forever, and it also goes up forever. So our range is all real numbers. And our asymptote. asymptote is at x equals 4. Any questions? Put your name on it and turn it up. Turn it in. Oh, Hayden, you coming back? Okay. Yes?